Hi, I'm Muhammad, a software engineer and a JavaScript developer. As you know, JavaScript is a single-thread language. So, it is really important to know how our codes will be running in JavaScript when we have some complicated codes and time-consuming functions. What will happen when a part of our codes may take a long time to complete? Should it block the thread and the entire process of our codes? Of course, no. We need to process them asynchronously. Therefore, the other codes will be processing and nothing will be blocked. And this is the goal of this video. In this video, we will take a look at some key concepts of JavaScript language, such as call stack, event loop, microtasks, and macrotasks. Call stack is a mechanism that is responsible for keep tracking of calling different functions. When a function called, the JavaScript interpreter will add it to the call stack and run it. If this function calls another function, which happens a lot, interpreter will add the called function to the call stack. We know that a stack is a LIFO data structure. LIFO stands for last in, first out. So the called function will be processed, and after finishing the process, the interpreter takes it off the stack and resume execution of previous function. This cycle will be repeated until entire functions get processed. Let's see a sample of call stack in JavaScript. For the examples of this video, you can go to this GitHub repository and download these files which are related to this video and continue coding with me in order to get a better understanding of this concept. So let's see the codes. We have three different functions here: the rock, the paper, and the scissor. You can see that we have only a console.log inside of these functions, and I have these functions play that has the calling the tree of functions, and I simply console.clear the console and play this function. So let's see what will happen if I run this. I will open a new terminal and I'm going to use Node.js for this course. So I say node and calling this file one-stack.js to run this file. So you can see that I have this rock, paper, and scissor happen. Let's see what's going on here. I call display, and inside of display I call three functions. The first one is rock, the next one is paper, and the scissor is the last one I called. So they will be go to the stack, and the first one will be rock, and it will be log this rock here in the console, and the first one is the paper. The paper will console.log the paper, and the next function will be logging the scissor for us. And you can see that the order of them are exactly like what we expected, and the first one is rock, and then it's paper, and the next one is scissor, and they run into this order. The next example is a little more complicated. Well, in the next example, we have this function open bank account, which gives a customer SSN or social security number, and it will check that if we can open a new bank account for a customer. Inside of this function, we call this function of check status, and we will give the output of this function into this check result, and we check the result, and we will console.log something respective to this result. And what is this check status? Let's see it. This is another function that gives a customer SSN, and then it will console.log checking a status started for this customer SSN. Then it will call another function, inquire criminal records for this customer SSN, and gives the result and save it into this check result variable, and it checks that, and depends on the result of this check result, it will log something into our console and return a positive or a negative. Let's see this function, and this is another function, and we have some comments here. It says that this function will check an checks an external API to the criminal records of this customer, and it will return the number of criminal records that found for the social serial number. If it found something, it will return the number of the folders, or it will return 0. 0 means that he has no criminal records. So this was the functions we had. First of all, I will clear my console using this command, and then I will call this open bank account with a social serial number. Let's run this function and see the result. I say that node to stack.js to run. Well, the first one is checking status started for this, and this is, let's see here, we call the open bank account. So the open bank account will be into the stack, and then it will call this check status. So this check status will come into the stack and it will be processing. Inside of this check status, it says console.logs that checking status for the number, and it happens here. You can see that. After that, it will call this inquire criminal records again. So this function will be into the stack and it will be processing. Inside of this function, we have this console.log. You can see that it is here, and we return, for example, 0 in this example. And because we are returning, this function is done. So it will be take off from the stack and we will come back to the top of the stack, which is the check status, and it was exactly here. So now we have this 0 inside of this check result, and because it is 0, this part will be executed, which is console.log. Check status was positive. You can see that here, and then it will return positive because it's returning. This function is done, and it will be take off from our stack, and it will be turned back into the open bank account because it is the last thing is in our stack. And here we have the positive. So because we have the positive, we are here. Because we have the positive, this part is true, so this will be run, and it says that console.log bank account created successfully, and we can see that this happens, and this is the order of calling our functions. But let's see another scenario. For example, let's say we have 2 criminal records and run this code again to see the results. Well, you can see that the order are same. With checking a status started for that, and calling external API for checking criminal records for this SSN. Then here you can see that because I'm returning 2 inside of this function, I will go here. There was a problem with check status, and this is the result, and it will return negative, and it will come back here into open bank account, and because this time it is not positive, it will come to here, and this part will be run, and you can see that there was a problem for customer check contact security department, and this is the another part which is here. So this was a little complicated examples that you will see a lot in the real world projects. Let's take a look at event loop. We know that JavaScript is a single thread language. In the background, it handles a lot of requests using event loop. The JavaScript event loop is a mechanism that allows the execution of JavaScript code to be non-blocking. It works by continuously executing tasks one by one from the task queue and allowing other codes to run between them. This means that a code can continue to run even if there is a long-running task being executed. Let's take a look at the event loop in javascript.info website. In this website, we have this definition. It says that the event loop concept is very simple. There is an endless loop where the JavaScript engine waits for tasks, executes them, and then sleeps, waiting for more tasks. The general algorithm of the engine: 1. While there are tasks, execute them, starting with the oldest task, and 2. Sleep until a task appears, then go to 1. And there is a formalization for what we see when browsing a page. The JavaScript engine does nothing most of the time. It only runs if a script or handler or event activates. It means that we have some tasks to do. So the tasks can be 2 different types: microtasks and macrotasks. Microtasks are small, high-priority tasks that are executed before any other tasks. Examples of microtasks include promises, mutation observer, queue microtask, and process.next tick in node.js. Microtasks are executed immediately after the currently executing task has completed. On the other hand, macrotasks are larger, lower priority tasks that are executed after all microtasks have completed. Example of macrotasks include set timeout, set interval, and UI rendering. Macrotasks are executed only after all microtasks have completed. Now that we understand the basic differences between microtasks and macrotasks, let's take a closer look at the key differences between them. Microtasks are executed before any other tasks, which means that they have a higher priority. Macrotasks are executed only after all microtasks have completed, which means that they have a lower priority. Microtasks are typically used for short, quick tasks that need to be executed immediately. And on the other hand, macrotasks are typically used for longer, more complex tasks that can wait until all microtasks have completed. Now, let's take a look at some examples of microtasks and macrotasks in JavaScript. We have some more examples here, and let's take a look at them. The first example is this. You can see that it's just simple three different codes, and let's run it using node file number 3. And you can see that it will log 1 to 3 respectively. Okay, let's go to the next example, number 4. You can see that I have this console.log start here, console.log end here, and inside of them I'm using this command q microtask, which will create a microtask here. Let's see the result. First, clear our screen, and then I run this file node number 4 dash event dash loop.js, and let's see the result. Start, end, and queue microtask. What happened here? The start runs in the first, the next one was the end, because these two lines were synchronous codes, and they runs in the first, and the next one is queue microtask. It means that this part of code will be a microtask, and it will run after all of our synchronous tasks, and this is the result of it. Let's see the next example. In this example, we have again that code, but in this time we have promise.resolve, and promise is one of the microtasks. And let's see the result of this code. I will run number 5. Let's see the result. You can see that we have the start, the end, and then the promise. The start, the end, and then the promise, which is a microtask, and will run after all of our synchronous tasks. Let's see the next example. In the next example, we have console.log start in the start. In the end, we have console.log end to see the order of its run. Then we have this queue microtask, which is a microtask, and it will console.log queue microtask. The next line is microtask with the type of promise, and we say that promise.result.then, which is will be run after this promise result, and we say that console.log promise. Let's see what is the result. I will clear my screen, and I say node file number 6 dash event dash loop.js, and start and end will be run in the first time because they are synchronous tasks, and this is okay. The next time we see that queue microtask will be run. This is the queue microtask, and the next thing is promise. What happened? These two commands runs in the first time because they are synchronous. After that, we have two microtasks, and they will be run respectively as they appear here. You can see that first we had this queue microtask, and then promise. It is here. And let's go to the next example. Next example is a little more complicated, and we have both microtask and macrotask. First, we have this console.log start here and console.log end, like the other examples. Inside of them, we have two types of tasks. The first one is a macro task. Set time out is a macro task, and we have just a console.log with set, it says set timeout with number of 0 and its time is 0. The next line is promise.resolve.then, and this is a microtask and it will log promise. Let's see the result of running this example. I say node file of number 7 event loop.js. Like the previous examples, we have a start and end, and this is the part we need to look at it carefully. The first one is promise, and the promise is executed first and then the set timeout of 0. Why this happened? Because this is a micro task and has a higher or priority, and the next one is macro task that has a lower priority. So this will be start in the first time and then this macro task will be run, and you can see in the result that this is the order of them. And let's see our final example, which is a little complicated, and let's look through it carefully. The first line is console.log start and the last one is console.log end. So we know that this is a synchronous command and this is also a synchronous command, and they are synchronous. The next line we have this set timeout, and its time is 3000 milliseconds or 3 seconds, and it will simply log set timeout 3000 milliseconds. The next one is promise.resolve.then, and it will console.log promise1. To see when it runs, it will log a promise and we can see its order of run. The next line is set timeout, but this time we have 2000 milliseconds and it will log 2000 milliseconds again. The next line we have set timeout, this time with 1000 milliseconds, to see how it is different with the others. In the next line again we have set timeout, but this time we have the 0, and it means that it should run immediately with no delay time. And in the next line we have promise.resolve again, and here we can say that we have promise2, and when it runs it will log promise2 and we can see when it will be run. So let's open our terminal again, type CLS to clear our screen, and we say node 8-event loop.js, and let's run it. Look exactly what's going on here. Well, you see that. Let's run it again, but this time look at them carefully to see what's going on. I will run this command again. You can see that I have this start end and something is happening. So what happened this time? Start and end was our synchronous command, so they started immediately. After that we have to promise 1 and promise 2. You can see that the promise 1 was here, and after that we had 3 set timeouts, and here we have promise.resolve promise 2, and you can see that the promise 2 was executed after promise 1. After that we have 4 set timeout, and this is the important part of this example. The first one is set timeout with 0, and this means that this one, the first command that executed. We know that set timeout is a macro task, so all of our macro tasks will be executed after our micro tasks, and these two promises was our micro tasks, so they started immediately after our synchronous task, and after that these 4 set timeout are executed. The first one was the set timeout with time of 0, because it will reach to the time of execution immediately. After that we had this with 1000, which was this one, and it means that after 1 second it will be executed and this will be logged into our console. The next one was this with 2000 milliseconds, and the next one was this with 3000 milliseconds, and this was the order of run of them. Let's clear the screen, and one more times let's see the event of this file again. 1, 2, 3. And this is the example that shows us the difference of synchronous codes and microtasks and macrotasks. It's good to remember that the differences between microtasks and macrotasks in the JavaScript event loop is crucial for optimizing your JavaScript code. By understanding the priorities and use cases of each type of task, you can make the most of the JavaScript event loop and ensure that your code is running efficiently. Thank you for watching this, and I hope you found this video helpful. Let me know if there is any opinion and leave some comments if there was any questions. Thank you. Goodbye.